Let us consider an elastic collision. To understand this, here I have shown two circles. The first one is a body of mass m1 and its velocity is u1. It is number 1, particle number 1. The arrow mark indicates that this particle is moving to the right. Take the second particle. Its mass is m2, its velocity is u2. It is also moving to the right along the same direction. Then, what is the condition for collision when the collision takes place? Obviously, when m1 has got more velocity. So, if m1 follows with more velocity, then only it can collide with m2. So, the condition for collision is u1 is greater than u2. The velocity of the first particle should be greater than the velocity of the second particle, then only collision is possible. When collision takes place, then there is a relative velocity of approach. The difference of velocities of 1 and 2 is known as relative velocity of approach. u1 minus u2 is known as relative velocity of approach. Its direction is to the right. The relative velocity direction is to the right. Then, in the middle, I have shown the two bodies in contact, that is, during collision. During collision, forces are applied on the two bodies. You notice F12 from left to right, F21 from right to left. F12 is the force applied by M1 and M2. F12 is the force applied by M1 and M2. F21 is the force applied by M2 and M1. F21 is the force applied by M2 on M1. So the momentum of first body changes due to the force F21, that is the force applied by second body, by the force applied by second body. The momentum of M2, second body, changes due to the force applied by first body, that is F12. Due to F12, the momentum of second body changes. Due to F21, the momentum of first body changes. Since the mass remains constant, the velocity changes. Let us suppose the velocities are v1 and v2. v1 is velocity of the first body after collision. v2 is the velocity of the second body after collision. Observe the arrows above m1 and m2. u1 is more, the length of u1 is more and the length of v1 is less. That means the velocity of the first body has decreased. Take the second body, arrows over second body, m2. The arrow over 2 is less than the arrow over v2. That means the velocity of the second body has increased. During collision, the velocity of the second body has increased. Now, u1 minus u2 is known as velocity of approach, and v2 minus v1. v2 is greater than v1. So, v2 minus v1 is called relative velocity of separation. That means the separation between m1 and m2 increases. The separation between m1 and m2 increases. Hence, it is known as relative velocity of separation. That relative velocity of separation is v2 minus v1. Its direction is also from left to right. It is also towards left. Now let us study an elastic collision using mathematics. Let us derive the relations that are applicable in elastic collision. We know that momentum is conserved and kinetic energy is conserved in elastic collision. In elastic collision, both momentum and kinetic energy are conserved. The conservation of momentum is written as m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. u1 u2 initial velocities of m1 and m2, v1 v2 final velocities of m1 and m2. So m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2 is this relation gives conservation of momentum. Conservation of momentum. Then conservation law of kinetic energy, that is the total kinetic energy before collision is equal to the total kinetic energy after collision. Half m1 u1 square plus half m2 u2 square is the total kinetic energy before collision. The total kinetic energy after collision is half m1 v1 square plus half m2 v2 square. So the total energy is conserved. Such a relation is written as half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. These two relations can be applied during elastic collisions. During elastic collisions, we can apply these two relations. From the first relation, by bringing m2 u2 to the right and m1 v1 to the left, by transferring m1 v1 to the left and m2 u2 to the right, we can write the relation as m1 into u1 minus v1, m1 into u1 minus v1, that is equal to m2 into v2 minus u2, m2 into v2 minus u2. This is the changed form of first equation. Now let us call this as equation 1. The second equation can be written as m1 into u1 square minus v1 square is equal to m2 into v2 square minus u2 square. That is, transfer half m2 u2 square to the right and half m1 v1 square to the left. Then you can write m1 into u1 square minus v1 square is equal to m2 into v2 square minus u2 square. Let us call this as equation 2. Let us call this as equation 2. By dividing 2 with 1, we get u1 plus v1 is equal to v2 plus u2. u1 plus v1 is equal to v2 plus u2. This relation is equation number 3. Now let us derive this relation. Equation 2 is m1 into u1 square minus v1 square is equal to m2 into v2 square minus u2 square. This is equation 2. Equation 1 is m1 into u1 minus v1 is equal to m2 into v2 minus u2. Now dividing 2 with 1, we write it as m1 into u1 square minus v1 square by m1 into u1 minus v1. On the right hand side, we write m2 into v2 square minus u2 square, m2 into v2 square minus u2 square divided by m2 into v2 minus u2. On the right hand side, m2 into v2 square minus u2 square by m2 into v2 minus u2. Now, on the left hand side, m1 gets cancelled because it is there in both numerator and denominator, it gets cancelled. Similarly, on the right hand side, m2 gets cancelled, and then we will get u1 square minus v1 square by u1 minus v1 is equal to v2 square minus u2 square by v2 minus u2. But you notice that u1 square minus v1 square can be written as u1 minus v1 into u1 plus v1. A square minus b square is equal to a minus b into a plus b. Hence, you can write it as u1 minus v1 into u1 plus v1 divided by u1 minus v1. u1 minus v1 gets cancelled and you will be left with u1 plus v1. Similarly, in v2 square minus u2 square, v2 minus u2 gets cancelled v2 plus u2 times. v2 square minus u2 square can be written as v2 minus u2 into v2 plus u2 divided by v2 minus u2. v2 minus u2 gets cancelled and we will be left with v2 plus u2. Hence, we will get the relation u1 plus v1 is equal to u1 plus v1 is equal to v2 plus u2. v2 plus u2. Now let us derive an expression for v1, that is the final velocity of the first body in terms of the initial velocities. Let us derive a relation for final velocity of the first body in terms of initial velocities of the two bodies. We have u1 plus v1 is equal to v2 plus u2. From this relation, we can write v2 is equal to u1 plus v1 minus u2. Bringing u2 to the left hand side and rearranging, we will write v2 is equal to u1 plus v1 minus u2. Now, the relation between momenta after rearranging, it can be written as m1 into u1 minus v1 into m2 into v2 minus u2. This was equation number 1. Equation number 1 is m1 into u1 minus v1 is equal to m2 into v2 minus u2. Equation number 1 is m1 into u1 minus v1 is equal to m2 into v2 minus u2. This is equation number 1. Let us substitute the value of v2 in this relation. Let us substitute the value of v2 in this relation. Then we will get m1 into u1 minus v1 is equal to m1 into u1 minus v1 is equal to m2 into u1 plus v1 minus u2 minus u2. m2 into u1 plus v1 minus u2 minus u2. That is equal to m1 u1 minus m1 v1 is equal to m1 u1 minus m1 v1 is equal to m2 u1 plus m2 v1 minus 2 m2 u2. m2 u1 plus m2 v1 minus 2 m2 u2. Let us further simplify this. m1 u1 minus m1 v1 is equal to m2 u1 plus m2 v1 minus 2 m2 u2. This can be rearranged as m1 u1 minus m2 u1 plus 2 m2 u2. That is, m1 v1 is taken to the right side and m2 v1 is also left on the right side, and the remaining quantities are transferred to the left side. v1 quantities are transferred to the right side and u1 u2 quantities are transferred to the left side. So m1 u1 minus m2 u1 plus 2 m2 u2 is equal to m1 v1 plus m2 v2. On the right side, m1 v1 plus m2 v1 is equal to m1 plus m2 into v1. m1 v1 plus m2 v1 is equal to m1 plus m2 into v1. The left side quantities which are transferred to the right side, they will be m1 minus m2 into u1, m1 minus m2 into u1 plus 2 m2 u2 plus 2 m2 u2. Therefore, v1 is equal to m1 minus m2 by m1 plus m2 into u1, m1 minus m2 by m1 plus m2 into u1 plus 2 m2 u2 by m1 plus m2 plus 2 m2 u2 by m1 plus m2. Expression for v2. To find an expression for v2, we have to eliminate v1. From the relation u1 plus v1 is equal to v2 plus u2, from the relation u1 plus v1 is equal to v2 plus u2, v1 is equal to v2 plus u2 minus u1, v2 plus u2 minus u1. Let us substitute this value of v1 in the relation m1 into u1 minus v1 is equal to m2 into v2 minus u2. This is equation 1. Let us substitute the value of v1 in equation 1. v1 is v2 plus u2 minus u1. Therefore, minus v1 is minus v2 minus u2 plus u1. Hence, we will get m1 into u1 minus v2 minus u2 plus u1. u1 minus v2 minus u2 plus u1. That is equal to m2 into v2 minus u2. m2 into v2 minus u2. Or 2m1 u1 minus m1 v2 minus m1 v2 minus m1 u2 minus m1 u2 is equal to m2 v2 minus m2 u2. m2 v2 minus m2 u2. 2m1 u1 minus m1 v2 minus m1 u2 is equal to m2 v2 minus m2 u2. Or 2m1 u1 plus m2 u2 minus m1 u2 is equal to m1 v2 plus m2 v2. v2 terms are taken to the right hand side. m2 v2 is already in the right hand side. Now take m1 u2 to the right hand side. Then you will get 2m1 u1 plus m2 u2 minus m1 u2 is equal to m1 v2 plus m2 v2. v2 is common. So we will get m1 plus m2 into v2 on the right hand side. On the right hand side, m1 plus m2 into v2. On the left hand side, 2m1 u1 plus u2 is common. Hence, we will get m2 minus m1 into u2. 2m1 u1 plus m2 minus m1 into u2 is equal to m1 plus m2 into v2. So, by keeping v2 and transferring m1 plus m2, we will get v2 is equal to 2m1 u1 by m1 plus m2, 2m1 u1 by m1 plus m2 plus m2 minus m1 by m1 plus m2 into u2. m2 minus m1 by m1 plus m2 into u2. This is the expression for v2. From this relation, we can calculate the final velocity of the second body after collision.